Today we're going over 3.2, all about functions notes. So we're going to start off with some definitions. We're going to start out with a relation. And a relation is just a set of ordered pairs. A set of ordered pairs. Ordered. And you're familiar with an ordered pair. We usually use them to graph x, y axis. So that's a relation. So anytime you see a set of ordered pairs, that's a relation. A function is a type of relation. It's a relation that has each x associated with exactly one y value. Okay, so what that means is that every x has to have a y value, but only that x can have the same y value. Domain. Domain is going to be the set of all x values. The set of all x values in a relation or a function. Range. Range is going to be the set of all y values. In a relation or function. Vertical line test. Okay, a relation is a function if a vertical line touches the graph at most one point at a time. So a vertical line test. A relation is a function if a vertical line touches the graph at most one point at a time. Okay, so there are four different ways that relations can be represented. They can be represented in a graph. They can be represented as an ordered pair. They can be represented as a mapping. And they can be represented in a table. Example 1. Represent the relation seen in the following ordered pairs graphically. Here's our set of ordered pairs as a table and as a mapping. So as our ordered pairs, if I do it graphically, I'm going to start at 0 and go down 5. 1, 2, 3, 4, 5 and plot my point. Negative 1, 4. So I'm going to go to the left 1 and go up 1, 2, 3, 4. 2, 6. I move to my right 2 and up 6. 4, 5, 6. Plot my point. And negative 2, negative 3. I'm going to move to the left -2 and down 3. And I have graphed my relation. In the table, my x values go here, so my first point is 0, -5. So I'm going to have 0, -5, -1, 4, 2, 6, and -2, -3. So I'm just placing the ordered pairs into table format with my x values and y values. A mapping, we have these two ovals and this kind of maps out where they are. My x's go in the first oval, so I have 0, -1, 2, and -2. And then I have my y values, -5, 4, 6, and -3. And the mapping, we use an arrow. 0 goes with -5, -1 goes with 4, 2 goes with 6, -2 goes with -3. So that's just a different way to look at our ordered pairs. What is the domain? The domain are all of my x values, so we use a bracket to contain them. And that's 0, -1, 2, and -2. So those are my domains. For my range, those are going to be my y values. -5, 4, 6, and -3. I'm going to end those with a bracket. Is the relation a function? Yes, it is. Every x has one y value. Going back to the definition of a function. 0 only goes with -5, -1 only goes with 4, 2 only goes with 6, and -2 only goes with -3. I cannot have two different arrows coming off of the x's. So each x has its own y. Example 2. State the domain and range of each relation and determine if it is a function. Okay, domain again is my x values. So I have -5 for an x value, 1 for an x value, 3 for an x value, and -5. So I'm looking at the first set of numbers in my ordered pair. Range, that's going to be my second set of numbers. Those are going to be my y values. 2, -2, 4, and -1. So I've gone ahead and looked at my second values for there. Is it a function? We'll see. Well, -5 goes with 2. 1 goes with -2. 3 goes with 4. Oh, I have -5 again. -5 is gone with -1. That is not a function. No. See, -5 is already with 2. It can't have a different y value. It has to have the same y value. So, y, -5 has two different y values, and that's not, we can't have that. It can only have the same one. -5 has two different y values. Okay, so they can only have the same value. So if I had -5, -1 twice, then it would be a function because it doesn't because it has the same y value. Example 3. We're given a graph and we want to determine if it's the domain and range, and we want to determine if it's a function. Alright, so my x values, so I'm going to come over here on my x and I'm going to determine where that point is. So I'm going to count 1, 2, 3, 4 spaces over. That gets me to this point here. So my first domain point is 4. Left to right is your x's. So my next, -4, excuse me. I went to the left 4, so that's -4. My next one is going out -2, and I'm working left to right. My third point is at 1. And my fourth point is at 1, 2, 3, 4, 5. So those are my domains. My range, I'm going to start at the bottom. I'm going down 1, 2, 3, 4, 5, 6, 7. So I have a point on the y value at -7. My next one is down at 1, 2, 3, -3. Then I have one at 0. And then I have one at 1, 2, 3, 4, +4. Okay, now I got -4 from the x coordinate here. I got -2 from the x coordinate here. I got 1 from the x coordinate here. And I got 5 for the x coordinate here. For my range, counted down to -7, -3, 0, and 4. That's where I got my numbers from. Now, is it a function? That vertical line test comes in handy. If I draw vertical lines through my graph, does that vertical line only touch at one point and one point only? And the answer is yes, it does. And what does that mean? That means each x has its own y, has exactly one y value. Each x has exactly one y value. Example 4 is in table form. So, what is the domain? Well, that's my x's. So I've got a 1, a 6, a 9, a 10, and I have another 1. I don't have to repeat it twice. I only write the domain once. What is my range? Well, those are my y's. I've got -3, -2, -1, 0, and 3. So I do write all of those out. Is the relation a function? Well, I have two different ones here. So I need to make sure that those y's are the same, and they're not. So since these y values are not the same for 1, this is not a function. Why? 1 has two different y values. Okay, it can only have one y value for number 1, and it has 2. Number 3, we have a mapping. And again, the domain, those are going to be my x values. So I'm going to come over here on the left side. Those are my x values. That's going to be 2, 1, 0, -1, and -4. And my range, those are going to be on the second oval. I've got 12, 5, 0, and -3. Is the relation a function? Okay, so 2 has one arrow, so far so good. 1, that one has 2 arrows. That's not so good. That means that 1 has two different y values. So right here I can go ahead and stop and say, no, that is not a function. Why? Because again, 1 has two different y values. Has two different y values. So if you see these arrows split off of one of the x's, that's not a function. Number 1 has two different y values. Number 1 can only have one of them. He can't have both of them. Okay, example 6. Vertical line test. Use the vertical line test to determine if the graphs below are functions. Okay, so if I draw a vertical line through my graph, I only touch one of the points at a time. So this one is a function. Okay, if I draw my vertical line here, do you see how I'm touching 3 of the points at one time? Yeah, that's bad. That's not a function. They can only touch one point and one point only. Not a function. Okay, so if I pass my vertical line through these points, I only touch one point at a time, so this one is a function. Here I have a line, so that means I have an infinite number of points. But if I pass the vertical line through there, I'm only touching one of those points at a time. So this fourth one is a function. Fifth graph, this is called an absolute value graph. And if I put my vertical line through, I only touch one point at a time, which is a function. This is a parabola, this curve shape, but if I pass my vertical line through it, see I'm touching it here and I'm touching it here. I can only touch at one point, so this is not a function. Okay, this little squiggly line, I don't have an official name for it, but if I'm going through with my vertical line test, I can see I'm only touching it at one point and one point only, so this is a function. I have an S line. So if I draw my vertical line through this one, I touch it once, twice, 3 times. So that's a bad thing. I can only touch it one time and one time only, so this is not a function. So the vertical line test is to help you determine if a graph is a function. It can only touch one point at a time. Only one. So if you can draw lots of vertical lines through there and only touch one point at a time, it's a function. If not, like our parabola here and our S-curve here, those are not functions. And we're ready to move on to our assignment.